Good morning, ma. Students, good morning. Am I audible?
Good morning, ma'am. Yes, ma'am. You're audible.
If you have any WhatsApp group, ask your friends to join the meeting. So, what are the topics that we have discussed in the previous class? Which topic we have seen in the previous class, ma? Do you remember the topics? We have seen routers, right? Routing, what will be the part of a router? Okay, internal structure of a internal architecture of a router. What is the difference between switching, forwarding, right? How forwarding will happen in switches? Why switch is called a self-learning device? Institutional network? What is the hierarchy? What is the purpose of virtual LANs? We started with virtual LAN, right? And what is the purpose of virtual LAN? How the segmentations can be done? How you can provide the limitations, that is broadcast domain, how it can be limited. So how can you configure the virtual LAN? Okay, it can be configured. Configurations can be done based upon port based or even based upon MAC address based. Okay, operations we have seen. And if I want to connect two switches, then instead of wasting multiple number of poles and wires, we can go for spanning across multiple switches can be done with the help of a trunk link, VLAN trunk. That's what we have discussed in the previous class, right? So we'll continue with that. Before that, I'll share my screen. Is my screen visible, ma?
Yes, yes.
Okay, so we're going to see VLAN trunking. Okay, so VLAN trunking and the tagging as well. That is 802.1Q. So how the frames can be identified. Before that, you need to understand what is VLAN trunking. So in a network, if I have multiple virtual LANs, okay, switches need to pass virtual LAN traffic across the physical link, right? So I have one switch, another switch. Okay, so it is having two different VLANs. This one is also having two different VLANs. Okay, so VLAN 10 and these ports are VLAN 20. Likewise, these ports will be connected to 20 and these are connected to 10. Okay, I want to connect these two things. Okay, switch 1 and switch 2. It can be done with the help of a trunk link. This link is called as a trunk link, okay, which will be carrying all the traffic. Okay, this is a trunk port which will be carrying all the traffic. It can carry traffic for multiple VLANs. Okay, for both the VLAN 10 and 20. For both the VLANs, this traffic will be carried with the help of a trunk port. Okay, so trunk port, usually it will be configured with the help of IEEE 802.1Q. Right? So this is all about VLAN trunking. So how does the switch identify the virtual LANs? It can be identified. So whenever I'm passing, this system is connected and it wants to share some informations to this particular system. Fine. So it has to pass the traffic with the help of a trunk link, right? So when a frame enters, it will be sending. So this switch will identify it is not part of this particular switch. So what will happen? It will be passing the traffic to this through this trunk port. So whenever a frame enters the trunk port, the switch will know. It must know which VLAN it belongs to. Okay, so this can be done with the help of VLAN tagging. Okay, that is the purpose of VLAN tagging. So VLAN tagging, for that only we'll be introducing one protocol which is called as 802.1q. So this will be adding 32-bit of information, that is actually 4-byte tag information will be added to the Ethernet frame. So whenever the traffic is passed from one switch to another switch through the trunk port, 32-bit more information, that is 4-byte tag will be added. Okay. So this tag will be placed between the source MAC address and the Ethernet type. So between this, VLAN tag information will be provided. So VLAN tag will contains a VLAN ID. Okay, so tag information, it is a 32-bit, right? So in the 32-bit, for VLAN ID, we'll be using 12 bits. Okay, to which VLAN we are sending the data. That can be identified with the help of 12 bits. Okay, so it can the range starts from 1 to 4094 different VLANs can be identified. That's the reason 12 bits are used. Okay, so standard frame size, Ethernet standard frame size will be 1518 bytes. Okay, together with that, I'm adding 4 bytes of information. So it becomes 1522 bytes. Okay, together with VLAN tag. So among from 1518, 18 byte of Ethernet header information will be there, and 1500 byte will be the actual information, that is the payload. So this is the payload and this is the header. Together, we'll be having 1518 bytes. Okay, so along when it is passed through a trunk port, 4 more bits will be added, 4 more bytes will be added for the VLAN tagging. Okay, so after VLAN tagging, the frame size becomes 1522 bytes. So why it is 1522? We have added additional 4-byte tag information is added. So this will increase the frame size, right? And also the default, usually the default MTU size will be 1518. Why? Because 1500 bytes for the payload and 18 bytes for the header, right? So now we have to increase the default MTU size. Okay, so the MTU, it may issue some packet drop or fragmentation. So that's the reason we need to increase the MTU size. Okay, some other devices, the default value will be 1588. In order to avoid the fragmentation, in order to avoid the packet drop, the MTU size has to be increased. So trunk ports, it relies on tagging information. So with the help of a tag, 4 bytes of information will be added. So among those 4 bytes, 12 bits will be used to identify the VLAN ID. Okay, to which VLAN a packet is sent. So these tags will increase the frame size. So MTU, you have to adjust the MTU in the switches, routers, even in the firewalls in order to avoid packet dropping. Fine. So how the VLANs will communicate with the help of a single link. Okay, this is your trunk link. Okay, so two VLANs, VLAN X and VLAN Y. Okay, with the help of a trunk link, two switches are connected. This is switch 1 and this is switch 2. Okay, so two switches managing two different VLANs X and Y. Okay, so VLANs, they logically segmented into the network. Okay, so these devices are connected to X and these devices are connected to another virtual area network, local area network, that is Y. Okay, so there is a trunk link which is connecting these two switches. So trunk link, what is the purpose of trunk link? It will carry multiple, in order to connect multiple VLANs. So the same link will be shared between both the switches, which works on different VLANs. Okay, a single physical connection is done between switches, so which will be carrying both the traffic for VLAN X as well as VLAN Y simultaneously. Okay, so whenever a frame leaves one switch through the help of a trunk port, what will happen? Initially, 32-bit information will be added to the packet. That is 4 bytes of information along with 1518 bytes. 4 bytes of information will be added. Okay, so among these 4 bytes, 12 bits will be used to identify the VLAN ID, whether it is for X or Y. Okay, so standard frame size is 1518. VLAN tag increases the frame size to 1522. Okay, so if any of the device does not support this increased size, obviously packet drop will happen. In order to avoid this issue, we have to increase the MTU size. Maximum transmission unit has to be increased, or else it should be adjusted. Okay, so the trunk link will be carrying both the traffic for VLAN X and VLAN Y simultaneously. It can be identified with the help of VLAN identifier, which is a part of VLAN tag. Okay, so each switch will be reading the tag and it will be forwarding the frame to the correct VLAN segment. Okay, so efficient and scalable communication can happen between both the switches. Fine. Any doubts? Any doubts as of now? Any doubts? Students, are you there in the meeting? Do you have any doubts? No one is there to reply. Very good. This is the way you are attending the classes, right? Anchal, Ajay, Alok, Anurag, Arjun, Ashish, Ayush, Vishwajit. Very good. For getting the answer, I have to call each and everyone individually, Amma. Even I got only one response. What about others? Are you there in the meeting? Please confirm by sending S message in the chat box. How many students are there in the meeting? Only one S out of 58 students. See? Not even 10% of students are there in the meeting. Simply connected. If I'm not getting responses, I'll just write to the coordinator. Don't make me to do, or don't make me to repeat the same thing again and again. Now we'll see the tagged and untagged frames. Okay, so what is the difference between tagged and untagged frames in virtual LAN? Okay, so what are tagged and what are untagged frames? So tagged frames, they will be adding certain tag information. So in order to identify the VLAN ID, right, to which VLAN the traffic is for. Okay, so that's the reason VLAN ID will be inserted into the VLAN tag. Right, inside the Ethernet frame, 802.1q will be inserting the VLAN tag, which will be where it contains a VLAN ID in order to identify to which VLAN we are sending the packets. So untagged frames, they will not, this is for the tagged frames. Right? So the tagged frames, the resultant will be 1522 bytes. Right? So what about the untagged frames? So untagged frames, they do not carry a virtual LAN tag. So the size will be 1518. So they'll be treated as a default frame or a native VLAN frame, which is a part of that particular switch alone. Okay. So ports that connect to end devices like printers, personal computers, other clients. So all everything are said to be the edge ports. So these ports will be sending and receiving the untagged frames. Okay. The switch internally nodes to which port which system is connected. Okay. So it can additionally add the tag information when it is internally pass a frame to other switch or over the trunk if it wants to pass the additional 4 bytes of information will be added and it will be passed to the trunk link. So trunk ports, what is the purpose of a trunk port? Trunk port is the one which will be connecting the two switches. Okay, switch to switch or switch to router will be connected with the help of a trunk port. Okay, which will be carrying the traffic for multiple VLANs. Okay, in order to identify, in that case, so this may have XY, this may have XY. Okay, so this Y wants to, system in Y wants to communicate in a system in Y of this particular switch. So it will be sending the packets, right? So in order to identify whether I'm sending the packets, whether this system sending the packets or VLAN X or VLAN Y, in order to identify that, the VLAN tag information is added. Okay, to each and every frame, the switch will be adding a VLAN. So this tag allows uh, the switch, whatever the switch that receives the packet, it can identify to which VLAN the frame has received. So it can route the frame to the correct VLAN. Okay, so the trunk port will be carrying both tagged information as well as untagged the frames. So one VLAN, uh, so within particular switch, if I'm passing the information, the VLAN tag will not be added. It is a untagged frame. It is a native VLAN frame. So if both switches, in this case, both switches must agree on which VLAN is untagged to avoid confusion or lost frames. So access ports here, access ports, they'll be using untagged frames. There is no need of tagged frames. Even the switch, whatever the switch that receives, through the VLAN ID, through the VLAN tag, it identifies the VLAN ID and what is the mission, and it removes the tag, and then only it will be sending the packets to that particular system. So each and every access port will have the untagged information. So only the trunk port will have the tagged information. Right? So untagged is a native VLAN frame. Right? So proper tagging has to be ensured in order to deliver the packets in a proper way. And isolation across a VLAN shared infrastructure has to be identified with the help of a tagged information. Fine. So VLAN trunking, the tagging versus untagged. So trunking, this is a central switch. As you can see here, this is a central switch. So it will be connected to multiple switches, right? So switch 1, switch 2, switch 3, and switch 4, and there is a central switch. Okay. So all these switches from switch to another switch is connected to the trunk port, and all the systems will be connected with the edge devices. It could be a client or server. Everything is connected to the access port. Okay. So these are called as access ports. So access ports will have the untagged information and the trunk port will have the tagged information. Okay. So the links between the central switch and each edge switch will be connected with the trunk port, and the systems are connected from the switch to edge devices will be connected with the help of an access ports. Okay. So these trunk ports will carry traffic for multiple VLANs over the same physical connection. Okay. So say for example, this can carry the traffic between 1, 2, 3. Okay. Why? Because these two things are connected. Okay. So from 2, it can carry the packets to 3. Okay. Likewise, this port can carry the information to all the multiple uh, VLANs can be can be routed with the help of a trunk port. Okay. So to keep VLAN traffic separate, each frame will be tagged with the VLAN ID with the help of 801 802.1q protocol. Okay. So the ports connecting to edge user devices, they are called as access ports. They can send and receive only untagged informations. Okay. So why? Because the switch internally can identify the systems directly. There is no need of tag information. So untagged information will be sent to the devices. So each device, say for example, if I'm taking a device in VLAN 2, it sends an untagged frame. The switch will be adding a tagged information whenever it has to route the traffic to the next VLAN. So that information can be identified or added with the help of a switch. Okay, so one VLAN can be designated as a native VLAN. So frames from one native VLAN will be sent without tags over the trunk frame. So both switches, all the switches must agree on native VLAN. Otherwise, there will not be any. Uh, so it can lead to routed traffic. In order to avoid that, we can have a native VLAN, or else you can have a different VLANs. Okay, so trunk ports, they allow multiple, they carry traffic for multiple VLANs, and all the edge devices will be connected with the help of an access ports, and they carry only untagged information. So access ports, untagged information, trunk ports, tagged information. You can even have a native VLAN. Even the native VLAN will have an untagged information, whether even it is connected through the help of a trunk port. It is an optional one that you have to decide. Right? So this is another example. We have here VLAN 10, VLAN 20, switch 2 is connected to VLAN 10, 20, and 30. And likewise, switch 3 is connected to VLAN 10, 20, and 30. So in order to span between these two switches, I want to have multiple systems. Okay, so these two are in different buildings, I say. Okay, in that example, in that scenario, we have to connect these two things. So this can be connected with the help of another switch. This switch to switch can be connected with the help of a trunk port. Okay, so VLAN 10 works in 10.0 and that is 172.17.10. So here 172.17.20.0/24. Here it is 172.17.30.0/24. You would have studied subnetting in computer networks itself, right? So we have all these three systems, and they are identified with the help of subnetting. Okay, and we have switch 2, switch 3. So these two switches are connected with the help of a switch 1. So switch 1 connects to switch 2, and switch 3, uh, both the switches are connected with the help of a switch 1. Okay, that too using a trunk port. As you can see here, this is the incoming and outgoing port numbers. Okay, so which are configured with the help of an 802.1q VLAN tagging. Okay, so in addition to that, we have VLAN 99. So VLAN 99 is nothing but a management VLAN, or else it is called as a native VLAN. So which works in 172.17.99.0/24. So that is VLAN 99. Okay, so it is a native VLAN. So frames for native VLAN, even that will be sent with the untagged information, that too with the help of a trunk port. Okay, so trunks will be configured to trunk carry all the four informations. We have four VLANs, like 10, 20, 30, and 99. Okay, so the devices, so 1, 2, 3, 4, 5, 6 are the personal computers. 1 and 4 are connected to VLAN 10, 2 and 3 for 20, and 3 and 6 for VLAN 30. Okay, so I need to connect uh, through this port numbers, all these things are connected. So access ports, they can send and receive the untagged information. Okay, so trunk ports will carry the tag information, but here especially for VLAN 99, even in the trunk port, it will not carry a tagged information. It will be for the management, and it will send the untagged information, especially for VLAN 99. Why? Because it is a native VLAN. So this will be identifying, this structure isolates the traffic between the departments. Okay, so a centralized switch is there, that is S1. Even with the centralized switch, the traffic is isolated. Fine. Any doubts? Do you have any doubts?
No, ma'am.
No, ma'am, no doubt.
Now we'll see uh, how to solve the customer conflicts. Okay, so VLAN tunneling with the help of 802.1q. So that too, uh, there is a scenario given. The service provider challenges is uh, reviewed here. Okay, there is a service provider. The service provider needs to carry customer VLAN traffic across its own infrastructure. Okay, so but there is a problem. Problem arises when multiple customers use the same VLAN ID. Say, for example, VLAN 10. Okay, so multiple customers they are using the VLAN ID VLAN 10. So this obviously it will cause the conflict. Okay, when the traffic travels the provider switches. Okay, the switch cannot tell which customer the VLAN belongs to. Fine. So there are only 4096 VLAN IDs possible. Why? Because we are using 12 bits. With the help of 12 bits, 1 to 4096 can be identified. Okay, so if we assign each customer a unique VLAN range, it limits the flexibility, right? So it limits from 4096. I cannot go beyond that. And also there will not be any flexibility and simply I'm wasting the VLAN ID, right? So if multiple customers wants to use the same VLAN ID internally, the provider cannot distinguish. Isn't it? That is another problem. So there is a service provider. Okay, service provider is there. So it can use 4096 IDs in order to differentiate the VLANs. Fine. But if the scalability issues comes and also I'm wasting multiple VLANs if only two our systems are connected to that particular VLAN. Okay, there is a problem here. This can be solved with the help of 802.1q tunnel, okay, which is called as Q in Q. Right? So 802.1q, it solves this with the help of two layers of VLAN tag. Okay, so this layers they have outer layer. Okay, so which will be used with the help of S tag, and there will be a inner layer that is called as C tag. Okay, so service provider tag, and this is the customer tag. Okay, so there will be two layers. Outer layer that will be added by the service provider, which will be identifying the customer connection, and there will be an inner layer, inner VLAN tag. So that is the customer tag. It will be managed by the customer. Okay, which will be identify the internal VLAN. So this allows multiple customers, they can overlap the VLAN IDs without any conflict. Fine. So the provider can assign each customer a single VLAN ID. Say for example, customer A. For customer A, am I using VLAN 100. For customer B, I'm using VLAN 200. Okay. So it will not run out of the VLAN IDs. Okay. So frames can be easily encapsulated with the two layers of VLAN tags. So the provider switches, they only look at the outer tag. Okay. So when it comes into the internal switch, the customer side will be using only the inner tag. Okay. So that to which VLAN it can be routed, that can be easily identified. Okay. So there is the problem here is there is a service provider. Fine, there are multiple number of customers will be there. Okay, fine. So the internally the customers will have multiple number of VLANs. Fine. So if this is the case, I can use 4096 identifiers as the outer tag, okay, which identifies the appropriate customers. Internally, they can even use 4096 VLAN identifiers, okay, which identifies the internal VLANs. Okay, so this is the advantage of using the VLAN 802. So IEEE 802.1q tunneling. That is Q in Q tunneling. So allows VLAN traffic from different customers to safely transfer a shared network. Okay, so customer VLAN structure will be preserved. Why? Because we are having two layers. Outer layer, which will have this service provider tag, and the inner tag will be for the customer. So customer tag can be, inner tag can be used to identify whatever the VLAN identifier, that is internal VLAN ID, can be used. Okay. So now we try to understand what is IEEE 802.1Q. Okay, so that is VLAN tagging standard. So 802.1Q, it is an IEEE standard. So how the Ethernet frames has to be tagged, okay, with the VLAN information that will be provided in 802.1Q. So it is used when Ethernet frames, it travels across trunk links between the switches. Okay, so the standard will be inserting 4 bytes of information into the Ethernet frame. So this will have a VLAN ID, which will be identifying the VLANs. So 12 bits will be used. So 1 to 4096 VLAN ID can be identified with the help of this 12 bits, which is a part of VLAN tag information, okay, which is a 4 bytes information. So it will be easily, it will be possible for the switches to easily identify and easily separate the VLAN traffic. Okay, so even the traffic is flowing across the shared links, it can be easily identified to which VLAN the packets have been routed. So since 802.1Q, it is a vendor neutral standard. So it allows multiple switches, allows different manufacturers, switches from different manufacturers, they can interoperate, they can exchange the VLAN tag information without any compatibility issues. Why? Because IEEE, it is a common standard. Okay, it is a standardized VLAN tagging. Okay, scalability, interoperable networks, easily supported with the help of 802.1Q. This is the advantage of IEEE 802.1Q. Okay, now we'll see the Ethernet, the tagged Ethernet frame structure. Okay, so untagged frame with the tagged frame. So it is a normal Ethernet frame. Okay, so standard Ethernet frame. So preamble, it is a 7 bytes. Okay, start frame delimiter, it is 1 byte. Destination address 6 bytes. Source address 6 bytes, and the type or length 2 bytes. Data, it ranges from 46 to 1000. The maximum is 1500 bytes. And CRC, cyclic redundancy check, for the error correction, it is 4 bytes. Okay. So why it is 6 bytes, not 4 bytes? Why the source address and destination address is 6 bytes, ma? Why it is 6 bytes? Why it is 6 bytes? So IP address is 4 bytes. But in the Ethernet frame structure, they are saying it is 6 bytes. Why it is 6 bytes? My question is, the Ethernet address is 32 bits. That is 4 bytes of information. But here the Ethernet frame says the source address and destination address is 6 bytes. I'm asking why it is 6 bytes. Mistakenly, they've written as 6 bytes, or actually it is 6 bytes, I'm asking. If in case it is not a mistake, then why 6 bytes? What is the size of the MAC address? What is the size of the MAC address, ma? Frames uses only MAC address, right? Packet will be using IP address. So packets will be used in network layer. Okay. So network layer converts the data into packets where it will be using the source IP address and the destination IP address for identifying the machines. The next layer is the data link layer. The packet will be converted into frames. It will be adding its own adder, its own header, right? Yes, because you're right. So frames will use only the MAC address. Okay, Ethernet frame, it is a part of a data link layer which uses the MAC address for identifying the source machine and the destination machine. Okay, MAC address is 48 bits or 6 bytes in length. That is the reason 6 bytes is provided here. So it is a standard Ethernet frame structure. Preamble, in order to say this frame is starting from here. Okay, start frame delimited and the destination address, source address, the type or length together with the data and CRC. Fine. The next one is the tagged frame. Okay, tagged frame, 4 additional bytes will be added, right? So previously itself I've told you between the address and the type or length, 4 bytes will be added. So preamble, source frame delimited, uh, destination address, source address, and you have 4 bytes of tag information. Okay, so 2 bytes for before type or length, a 4-byte VLAN tag is inserted between the source MAC address and the type of length field. Okay, so this is totally 2 TPI plus 2 tag. Okay, so 2 bytes for tag protocol identifier. It is a tag protocol identifier that is for 2 bytes. Okay, so which always it will be set to 0x8100. This is the hexadecimal value which will be set for the TPI. So if the TPID is set to 0x hexadecimal value 8100, it will be identifying it as a tag information. Okay, so it is a VLAN tagged frame. Okay, and you have 2 bytes for tag control. That is, this is for identifier and this is for the tag control information. Okay, so here 2 bytes in the sense it is 16 bits, right? So out of this 16 bits, 3 bits will be used to identify the priority. 1 bit will be used to identify the CFI and 12 bits will be used to identify the VLAN ID. Okay, so 3 bits for the priority. Okay, so 1 bit used for CFI, canonical format indicator. So mostly it will not be used. And these 12 bits will be used to identify the VLAN ID. So from 1 to 4096, it can be identified. 4095, it can be identified with the help of this 12 bits. Right? So the 4 byte is added, right? So the maximum frame size, now it will be changing to, if my payload is 1500, if I'm using the data, all the data together. So my frame size will be 1522 together with the tag information. So we have to ensure this MTU size has to be restructured. Okay, we have to configure the MTU on the trunk lanes. Okay. So 802.1Q, the tag will have 4 extra bytes in order to identify the VLAN identity. So that the switch will know which VLAN the frames it belongs to, whether I'm sending for VLAN X or Y is it. So easily we can uh, route the traffic. For that, the reason the 2 TPI and 2 bytes for tag is added here. Right? So this is an example. So this is the original frame without the VLAN tag. Okay. So destination MAC address, you can see the destination, the frame size, it says 1518 bytes. Okay. So the source address, this is my source address and this is the destination address. Okay. Destination source MAC address and the destination MAC address is provided here. Right. So this is the source destination MAC address. This is the source MAC address. Type is IP, that is 080800. It is an hexadecimal number. So IP protocol version is 4. The IP address is provided here. Okay, right. So there is no VLAN information is present in this normal original frame. Okay, but as you can see here in the tagged information, so 802.1Q virtual LAN, already I've told you the TPI, whenever you include tag information, so the TPI will have the default value as 0x8100 in order to indicate this is the tagged frame. Okay. So together with that, the priority is set to 0, CFI is set to 0, and the ID, VLAN ID, here it is mentioned as 32. Okay, so what is the ID? The ID is 32. Okay, so 32 indicates this is the frame which is sent for the VLAN, which is numbered as 32. Okay, so 3 bits for the priority, 1 bit for CFI, and ID 12 bits. Okay, so whenever a switch receives this tagged information on a trunk port, it will be reading the VLAN ID. So what is the VLAN ID provided here? So it will determine which VLAN the frame belongs to, right? So here it says this packet is belonging to the virtual VLAN 32. Okay, so multiple VLANs, the traffic will be carried for the multiple VLANs, right? So the single trunk link will carry the packet for the multiple VLANs, right? So through this information, I can differentiate to which VLAN the packet will be sent for. So in this example, they say this is for VLAN 32. Okay, so the frame size will be increasing from 1518 to 1522. Why? Because 4 bytes of information will be added. So 4 bytes, 2 bytes for TPI and 2 bytes for tag information. So TPI always it will be set to 0x8100 for tagged information, and priority 3 bits, CFI 1 bit, and 12 bits for identifying the VLAN ID. That is 2 to the power 12, that is 4096. By default, 0 will not be included. So from 1 to 4095, I can differentiate the different VLAN ID. Right? Any doubts?
No, ma'am.
No, ma'am.
Now we'll see how the forwarding can be between the VLANs. Okay, that is inter-VLAN routing. So VLANs, they are logical switches, right? Even in this example, two VLANs, we have two local area networks. Physically, it is a one switch which will be connected to multiple systems. But logically, as you see here, there are two local area networks. That is local area network 1, that is a part of electrical engineering. 2, it is a computer science engineering. Okay, from ports 1 to 8, it is connected to electrical engineering. Ports 9 to 15 are connected to computer science engineering. So if I want to send the packets from one virtual LAN to another virtual LAN with the help of a router only, that can be done. That's the reason these two ports are connected to a router. So this system in electrical engineering department can route the packets to computer science department with the help of a router. Okay, only through the router it can be sent. Directly through with the help of a switch, it cannot directly send the packets. Okay, through the router only it routes the packet. Okay, so it logically separates the switches. Okay, through the ports we can configure two virtual area networks. Okay, so that is VLAN. I'll take VLAN 10 and VLAN 20. In this example, VLAN 10 and 20. So for example, it is connected to 10.0.10.24. Here it is 10.0.20.0/24. Okay, so the devices within the same virtual area network, they can communicate directly. So devices in different VLANs, through the router, it can communicate with each other. Okay, so like two devices on the separate physical switches in different subnets, they cannot talk with each other without a router. That's the reason two logically separated LANs can be connected with the help of a router. Okay, so this is where your internal VLAN routing comes in. Okay, so routing between the VLAN will be done. It can be done with the help of either the layer 3 switch or through the help of a router. Okay, so these devices can route the packets between the VLAN subnets. Okay, so integrated switch or the router devices we can use for the inter VLAN routing. Okay, now we'll see one scenario. A single switch. Here it is divided into two VLANs, right? So in the previous example itself, the single switch is divided between two VLANs, that is VLAN 10 and VLAN 20. Okay. If I take the, or else these are connected to systems VLAN 10 and these are connected to systems VLAN 20. Electrical engineering, and this is for computer science. Okay. So no systems from one VLAN to another VLAN, they can communicate directly. So if they want to communicate, it can be done with the help of a router or a layer 3 switch. So the router will be connected with the help of a trunk port. Okay, so this connection, the router can receive the tagged information from multiple VLANs. Okay, so within VLAN, communication between the PCs can directly done through the help of a switch. No router is needed, but between the VLANs, the communication can be done with the help of a router or a layer 3 switch, that too via a trunk link. So the trunk link will carry the VLAN tag. Okay, so that's what we have seen in the previous example, right? So in this example, a scenario is given. So a service provider, the service provider want to carry or transfer the customer VLANs across multiple managed provider managed switches. Okay, so VLAN ID conflict will be there. Why? Because it is limited to 4095. Only 4095 IDs can be used. So customer VLAN numbers may overlap with the VLAN IDs, right? The customer can use 20 and even the service provider can use 20. Okay, this cannot be identified. So how to solve this? With the help of two-layer QNQ with the help of tunneling. Just now we have seen, right? So two layers, outer layer will be for the service provider and the inner layer will be for the customer, right? So with the help of this, we can uh, solve this problem. Actually, we have seen that, right? Now, we'll see what is double tagging. Okay. So what is double tagging? When double tagging is required, so each packet it will be getting the what is double tagging? Two VLAN tags will be there, right? So with the customer VLAN tag together with the service provider VLAN tag. So what will be the outer tag for the customer and the inner tag, sorry, outer tag for the service provider and the inner tag for the customer. Okay. So this allow customer VLAN traffic can be transferred. It will be transparent, right? So we can transparently carry the packets across the provider's network without any interference. Okay. So the inner tag, VLAN tag will be carry the VLAN ID, which will be chosen by the customer. So whatever the customer that is chosen, the VLAN ID, those informations will be part of VLAN inner tag. The outer tag, it tells the service provider tag. Okay. It will be inserted by the service provider and it will be used for the tunneling purpose. So why double tagging? VLAN, the customer tag and the service provider tag will be in the separate namespaces. Okay. So for, say for example, the service provider is providing the VLAN tag 101 and even the customer is providing the VLAN tag that is 101. Okay. So the same time, if I'm using the same tag, there will be a conflict. So without us, if I'm using only one tag 101, with this, I cannot identify whether it is for the customer or the service provider. Okay. And also it is limited to now 4095. In this case, I can easily identify the service provider is also given 101 for that particular customer. And the customer tag is also carrying 101. Okay. So even internally, the customer can give the virtual LAN identifier is 101. So these can, you can, the conflict will not be there. So multiple customers, they have different VLANs. At the same time, the service provider can use the same ID. Okay, there will not be any conflict if two layers of information is given. Okay, and also the scale up will be good. Why? Because 4095 here. So within the customer, again, the customer can use 4095, right? So 4095 into 4095 IDs can be used. That is the advantage of double tagging. So each extra VLAN tag will be adding 4 bytes to the Ethernet frame. So when double tagging is used, you have totally 8 bytes will be added, right? And also here again, the MTU size has to be adjusted. Okay, so when the double tagging is used, 4 bytes, that is 1522 again plus 4, it becomes 1522 plus 4, 1526 bytes will be used for the frame size. The MTU size, you have to adjust the MTU size in order to avoid the packet drops. Okay, so by default, what is the size? 1518. Now it has to be adjusted to 1526. Fine. Any doubts, ma'am? Any doubts?
No, ma'am.
No.
What about others? Shall I continue? Now we see 802.1q tunneling. That is tagged traffic in the asymmetric links. Okay. So the customer devices, they'll be sending VLAN tagged traffic with the help of 802.1q trunk ports. Right. So the tagged frames will also enter the service provider network with the help of a trunk port on the edge switch. Right. So which is the edge switch? This is the switch. Multiple VLANs will be connected. So this is VLAN 1, VLAN 2, and VLAN 3. Switch 1, switch 2, switch 3, and this is the edge switch, which will be connected to the service provider. Right? So here, this is the trunk port. Also, this is a trunk port which will be carrying the frame, the tagged information will be entering into the service provider network. Okay, with the help of a edge switch, it will be connected to the service provider. Even the service provider switch to the service provider, layer 3 switch, or even the router will be there. So a switch to router will be connected with the help of a trunk port. Okay. So what is the purpose of tunneling? So the tunneling is required to preserve the customer's VLAN type. So in this example, so I have identified 2, 3, 4. Here 5, 6. So how many VLANs are there? So 1 to 6 VLANs are there. Okay. So this is the customer network. Okay. So customer is configured. I'll take 10, 20, 30. Again here 30, 20, 30, 40, 50 and 60. Okay. So 10, 20, 30, 40, 50, 60. These are the IDs used within the customer network. Okay. So the service provider also used this part will be identified with the help of a VLAN ID, right? So here the service provider is given 30, right? So the frame has included only 30. How the customer could be able to identify whether it is for whether I want to pass it to the service provider or whether it has to be passed to the another internal virtual area, local area network. That is, it cannot be easily identified, right? That is the reason tunneling is required. So tunneling will preserve the customer VLAN tag. Okay, so it will be encapsulating within the service provider VLAN tag. So outer tag will also say VLAN 30 and the inner tag also will say VLAN 30. So outer tag VLAN 30, it says it has to be routed to the outer service provider. Okay. So whenever, service from the outer service provider, the packet comes in. Say, for example, if I'm taking that as an example. Okay. So when it enters to the edge switch, it will be identified by this switch, whether it has to be routed to switch 1 or switch 2. Okay. So if it is for switch 2, the edge router will be routing the packet to the switch 2. So switch 2 will identify to which system it has to be routed. So this is for this particular network to which switch system it has to route. That can be identified and it will be directly routed. So this will be untagged information. Here it will be the tagged information. Together here also it will be a tagged information. Okay. So one end will be connected to the customer's 802.1 Q trunk port. Okay, so this is the trunk port. Okay, another edge, the edge switch, one end will be connected to the customer's port, another end will be connected to the provider's tunnel port. Okay, so this, if I'm not, if directly if I'm saying 30, the mismatch will be there in the port configuration. Okay, it makes the link asymmetrical. So each tunnel port on the service provider switch will be assigned to the unique VLAN ID as VLAN, right? So this will not be visible to the customer. So in order to ensure the traffic from each customer, it should be isolated. In that case, uh, we'll be using tunneling. Okay, two layers will be used, one for the service provider, another for one for the customer. So this setup will support multi-tenant environments. Okay, so conflict will be avoided. It can scalable. The IDs can be scalable so that I can use 4095 to 4095 combinations of ID. Okay, so especially it will be useful for the internet service providers or the enterprise networks. Okay, so where you have the virtual LAN is acting as a backbone. In that sort of networks, it will be very useful. Fine. So now we'll see an example for the 802.1q tunnel ports in the service provider network. Okay. So this diagram, it shows the service provider how it uses 802.1 tunneling to transport the VLAN tagged information from multiple customers, okay, within the shared infrastructure without having a VLAN ID conflicts. Okay, so there are customers, customer A, customer B. So here also there is a customer A and customer B. So two customers, customer A uses VLANs 1 to 100 at multiple locations. Okay, so this is one location and this is another location. Likewise, the same customer B uses 1 to 200 at different sites. Okay, so both the customers uses 802.1q trunk ports to tag their own traffic. Okay, that is for the customer VLAN identifier. The service provider network, it consists of multiple tunnels. Okay, tunnel ports are there, which will be configured to ES-VLAN identifiers. Okay, through the SVLAN identifier, it will be configured. Okay, so in this example, they say VLAN 30. It is for this tunnel port. Okay, so this is for this tunnel port. And VLAN 40 for customer B. For customer A tunnel port, it is for VLAN 30 and customer B tunnel port is VLAN 40. As you can see here, the 30 is assigned to customer A and 40 VLAN 40 is assigned to customer B. So this tunnel ports will be adding an outer VLAN tag. Okay, that is for the service provider VLAN. Okay, for the incoming frames. So it will be encapsulating the customer's tag. Okay, so these lines indicate asymmetrical links. So one end is connected. So see here, one end is connected to the outer switch, that is the service provider. Okay, provider tunnel port, and the another end is connected to the, in this case, it is connected to the tunnel port, service provider tunnel port, and other end here it will be connected to the actual customers. Okay, so the customer's 802.1q tunnel port. So this setup will have a customer tagged information also will be entering into the service provider's network without I don't want to alter the inner VLAN identifiers. Okay, so the VLANs can be, I can reuse across the different customers. So without any conflict. So say for example, if I want to, so in this example, I'll take so 10, 20, 30, even 40. Okay, so whenever a packet comes in here, so it will indicate yes, VLAN ID is 40 and the customer VLAN ID is 40. The information, the preamble, source, destination, address, FRC, everything will be included here. Okay, so together 1526 bytes will be there. Whenever it comes in, this switch will take out this part and it will read C40. Okay, so this has to be routed to this particular network. Okay, so this will eliminate this and it identifies this is for this particular virtual LAN. Okay, so internally there will be a switch here, right? So, uh, so incoming packet, this is the packet. So it will remove this and it will send this tag information. This is a trunk port as well as this is a trunk port, right? So customer 40, this packet, excluding this service provider information, this part will be there and it will be given to the, why? Because it is a trunk port. Okay, so it will also carry the tag information. Okay, and it will be sent to this particular switch. So the switch will discard this information. Okay, so based upon the destination address, it will identify it as for this particular, say for example, 10.0. In this example, they've taken what? Oh, okay, so 20.25/24. Okay, this is the destination address. So directly it will be routing the packet. So it will remove this tag information. This is the access port. In the access port, only the normal frame will be sent. Okay, so this is how it will be encapsulating the information. So the service provider will include the service provider VLAN tag and the customer's VLAN tag also will be included. Okay, so this tunnel port will have both the identifiers. When it comes to the edge switch, the edge switch will will exclude the service provider information and it will have only the customer tag information and it will be sending the information. The edge switch will be sending the information about the customer tag to the internal switch. Okay, so this switch will identify to which network the packet belongs to. It discards the tag information and it will be sending the actual frame, removing the tag information and it will be sending the packets to the destination. Fine. Any doubts, ma'am? Now we'll see 802.1Q tunneling. Okay, so the traffic from the customer device will have a customer VLAN identifier as well. So the customer tag will be represented with CVLAN and the service provider tag will be represented with the help of SVLAN. Okay, so outer tag will contain the customer ID and the inner tag will have the customer VLAN identifier. Okay, so the type, ether type, already I've told you, ether type field, that is TPI, has to be mentioned as 0x6100. Okay, and also the COS, the class of service, and also the SVLAN ID will be added in the outer tag as well. Okay, the double tagged frame will be used for the tunnel traffic. Okay, so it travels across the service provider networks with the help of tunnel VLAN, and the tunnel ports will enter into the edge switch. The head switch will be discarding the service provider tag. Only the customer tag will be taken and it will be routed to the internal switch. Internal switch, again, it will remove the tag information and based upon the destination address, it will be forwarding the packets. Okay. So the outer packet, the outer tag will be removed whenever it enters into the edge switch. Edge switch. Okay. Whenever it enters into the internal switch, it removes the VLAN identifier as well. Okay, so only the access ports will carry only the normal Ethernet free. Okay, so this is how the traffic will be tunneled and the customer's trunk port will be retained. The tag information still it will be remained in the customer VLAN tag and it will be delivered to the appropriate one. So for the commands, as you for configuring, we need to if it is in Cisco devices, if you want to configure, then I have to use the commands, related commands like switch port mode dot 1q tunnel. Okay. So double tag informations, right? So over the 802.1 tunneling, if I want to include, then you have to say it is a switch port mode dot 1q tunnel in order to support both the service provider VLAN tag as well as the customer VLAN tag. So the layered tagging informations, it has to allow the provider to transport multiple customer VLANs. Okay, many of which uh, without overlapping, if I want to include the VLAN ID without any conflict, you have to use the tunneling information. Okay, so for that, this command will be used. Fine. So 802.1q tunneling, it is also called as Q in Q tunneling, right? So it will be carrying the double tagged informations. Okay, one for the uh, service provider and another one for the customer. That's the reason it is called as double tagged frame. Okay, so whenever it enters into the edge network, edge switch, the outer tag will be removed. And again, it enters into the internal switch, the outer tag will be removed. Okay, so only the frame will be traveled. Okay. Now we'll see the frame format. Okay. So the first one is preamble, source frame delimiter, destination MAC address, source MAC address, ether type, payload, CRC or FCS, frame check sequence. Okay. So no VLAN tagging is provided here. It is a normal native Ethernet frame. Okay. The next one, as you can see here, preamble, SDF, SFD, destination MAC address, source MAC address. So here 801.Q header is added. This is for TPI. So which will be set to 0x8100 in order to indicate it is the tag information. Okay. As you can see here, another information, another 2 bytes of information is also provided here. Okay. So which includes priority, CFI, and also the VLAN ID. Okay. So priority 3 bits, CPA 1 bit, and VLAN ID, it is 12 bits. Okay, so this is the outer tag, sorry, inner tag. Okay, so when it enters from the edge switch, when it is moving to the service provider, so see here, another, this is the outer tag, which contains the customer tag information. This is the, sorry, this is the inner tag. This is the outer tag, which will be having the service provider tag information. Fine. So the tag related to the service provider. Here also the TPI will be set to 0x8100. Fine. So it also includes the 3 informations like priority, CPI, and also canonical frame format, CFI, and also the VLAN ID. Fine. So encapsulation will be there. So this is the outer ID, which carries the tag information related to the service provider. And again, 4 bytes of information will be there. That is the inner tag, which tells the customer VLAN identifier, customer tag information. So 802.1q, it is, you have an extension version of 802.1q. That is 802.180. It is an extension of 802.1q. Okay, multiple, it will be enabling multiple VLAN tags can be provided in a single Ethernet frame. Okay, so it will be used by the service providers for encapsulating the customer VLAN identifiers. Okay, so it will start with the untagged, always the tag insertion will start from the empty or else the normal Ethernet frame will be taken. From that, we'll be adding the customer identifier. Okay, so normal Ethernet frame will be taken. So when it passes to the switch, to the edge switch, it will be adding the customer tag information. Customer VLAN identifier will be there. For that, we'll be using 801Q header will be there. Okay, so which includes the TPI, which will be set for 0x8100, and also the tag information will be included. Okay, so from the edge switch, when it goes to the service provider, S tag will be added. Again, for that, we'll be using 802.1Q, which will be using both the tag information, service provider tag information, as well as the uh, TPI, which will be set to 0x8100. Okay, so outer type, sometimes it also uses another value in order to indicate that is the outer tag. Optionally, it uses 080x88A8. Okay, in order to differentiate from the customer tag. So customer tag, yes tag TPI value will be 0x88A8. This is for the outer tag. And customer tag, that is the inner tag, the TPI value will be 0x8100. Okay, so in order to differentiate between the customer tag and the service provider tag, the TPI value of the outer tag will be 0x88A8. So it indicates that is the outer tag. Fine. And this is for the service provider. Fine. So this is the extension version, that is 802.1 AD, that is uh, for spanning multiple tunneling information. Double tag when it is double tagged. Right? Now we'll see VLAN translation. So what is the purpose of VLAN translation? So service providers will be mapping the customer VLAN identifiers to the internal service VLAN identifiers, right? So customer networks, uh, there may be a conflict with the VLAN IDs without any issue. Okay. So in that case, the VLAN translation is required so that we can configure the trunk ports that can be connected to the customer networks. So the mapping can be based upon the port numbers or customer VLAN value in the incoming packet. Okay. So what is the translation type? So the translation type, it can be of three types. Okay, so translation can be done based upon the three types. All in one. So we can bundle in as all in one, or many to one bundling can happen, or else we can map. Mapping can be done for the specific interface. So for the first translation type is all in one. All in one in the sense all the customers VLAN will be bundled into this single service VLAN. Okay, so it simplifies the backbone routing. Say for example, the customer VLANs which are numbered from 100 to 10, 100 to 200, it has to use the service provider VLAN identifier as 200. Okay, so easy, right? So from customer 100 to 200, they have to use the service provider VLAN ID as 200. Okay, it will be very simple, right? This is all in one. And also the second type of translation is many to one. So many to one in the sense multiple customer VLANs can be mapped to a single VLAN. Okay, so more selective than compared to all in one. So the customers uses a subnet of virtual LANs. In that case, we can map it. Say for example, if the customer is using the subnet ID as 20, 30, in that case, they have to use the VLAN ID as 100. Okay, so this is many to one. Okay, and also the third type is mapping on the interface. The translation can be based upon the port number. Okay, so port based VLAN mapping granularity control can be given. So say for example, the port number, this is for customer VLAN 10. It should be mapped to the service provider VLAN 100. So this type of mapping can be done. So three types of translations. The first one is all in one. Second one is many to one. And the third type based upon port based VLAN mapping can be done. Okay. So VLAN conflict can be eliminated between the customers. So multi-tenant environments can be provided for the flexibility for managing the networks. Fine. Now we'll see some of the mapping configuration examples here. So map VLAN IDs 1 to 5 in the customer network to VLAN IDs 101 to 105 in the service provider network. How to? This is one-to-one mapping. Okay, so how to give one-to-one mapping? So each customer VLAN, that is the customer VLAN, will be translated to the unique service provider VLAN SLAN. Okay, so for that you will be using the interface giga with Ethernet 0 bar 1 switch port VLAN mapping. VLAN mapping one has to be mapped. This is the customer VLAN identifier. So customer VLAN identifier one has to be mapped to the service provider VLAN identifier 101. So customer two VLAN ID has to be mapped to service provider VLAN ID 102. So 3 has to be mapped to 103, 4 to 104, 5 to 105. Okay, so other VLANs has to be dropped. Okay, so see here VLAN mapping default drop. So other than this, everything has to be other VLANs are to be dropped. So this is one-to-one mapping. Okay. So the next one is many-to-one bundling. So many-to-one bundling in the sense we'll be bundling all the traffic to the VLAN. Okay. So in this example, the SVLAN has to be mapped to 100. All the incoming VLAN traffic will be tunneled with a single outer VLAN tag that is 100. Okay. So see here, switch port mode. It is a trunk mode. Okay. I need to say it is not the normal mode. It is access. It is not an access port. It is a trunk port. So switch port trunk allowed is 100. Okay. So all the customer traffic regardless of customer VLAN ID, it has to be encapsulated with the service provider VLAN ID 100. So the VLAN mapping default 80 dot 1 Q2 dot 1 Q tunnel, that is default value is 100. So we are mapping. So either whatever the customer VLAN identifier is that it has to mapped with the service provider VLAN 100. Okay, so this is the many to one bundling. The next one is selective bundling, selective QNQ mapping for the VLANs. So see here, so the mapping VLAN identifier. So whatever, only the VLANs from numbered, which are numbered 1 to 5 can be tunneled to the ES VLAN 100. Okay, so other VLANs you have to discard. So here the drop notation is not given. So for all the customer VLANs, the service provider ID will be mapped to 100. Here 1 will be mapped to 101, 2 will be mapped to 102, 3 will be mapped to 103. Likewise, 5 conditions are given. Other VLANs has to be dropped. Okay, in this case, it is a selective one. So many things are grouped and VLANs which are the customer VLAN IDs which are numbered from 1 to 5, it has to be tunneled for the customer service provider tag number 100. Other all other VLANs has to be discarded. Okay, so this will be used at the customer edge to the provider edge connections. Okay, this configurations can avoid the VLAN isolation. It controls the tunneling. Okay, so regarding the complexity, if the network grows, the VLAN based segmentation, it is hard to manage them. Okay, so the complexity becomes critical. In that case, we have to replace the switch. Okay, so the switch replacement, plug and play. You cannot just swap out a failed switch. Okay, this new switch you have to add. You have to manually configure with the same VLANs, trunk settings, spanning tree settings, everything, the backup configurations, everything has to be managed. Okay, so that is the one problem. Okay, and also field technicians are required. Okay, so higher skill set is required. Why? Because simple layer 2 knowledge is not enough. Why? Because the technicians must understand the trunking protocols, that is 802.1q. Okay. And if the VLAN mappings are done, the configurations again manually you have to reconfigure it. Okay, so Q and Q tunneling is required. How to trace the VLAN paths through the network that are more difficult, right? And also the trunk links must carry the correct VLANs, isn't it? So inter-switch trunks must be configured so that it should allow only the necessary VLANs. Others has to be discarded. Okay, so missing VLANs on a trunk, it breaks the connectivity. If I'm missing, so from 1 to 5, instead of 1 to 5, I'm saying 1 to 4 for the selective mapping. I'm going for 1 to 4. I'm missing 5. All the packets will be dropped. So it gives you the broken connectivity. Okay. So it requires consistent, careful configuration is required. Okay. So even if I'm adding certain things, so if I'm adding a VLAN, that has to be propagated to all the switches. So whatever the switches are connected to that relevant switches has to be propagated, right? And also the trunk ports, even the trunk ports must be updated so that the new VLAN can be shown to the other switches as well. Okay, so this is for adding a VLAN. If I'm removing a VLAN, so adding is okay. So if I'm removing a VLAN, again a cleanup process is required on the trunk links, access ports. Okay, so breaks, if I'm mistakenly, if I'm instead of removing 4, if I'm saying 5, break connectivity happens. Okay, still using the VLAN. The problem is there. Okay, so in order to avoid all these issues, you can go for VTP. So VTP is nothing but VLAN trunking protocol. So VLAN trunking protocol will manage the VLANs across multiple switches. So it will maintain the documentation for VLAN IDs. So whatever the usage, what is the trunk port configuration, everything will be maintained by the VTP. Okay, so it will be using the configuration backups, the templates. So what is the switch replacement? Or what can be the fastest switch replacement? How to implement the monitoring tools? With the monitoring tools, how can I verify the consistency across the network? So everything can be done with the help of a VTP. So VTP is nothing but, so you can go, if you want to manage the VLAN complexity, then you have to go for VTP. VTP is nothing but VLAN trunking protocol. Right? So what are the good reasons to use VLAN? So efficient network segmentation without extra hardware. In that case, I can go for, you need to segment your network into different subnets, okay, based upon the department. But you cannot afford a multiple physical switches. In that case, you can go for the logical separation. So logical separation, a single switch can be using a different VLANs. In that case, we can go for a VLAN. Okay. So how to hide or isolate the traffic that is sensitive infrastructure, like devices like iPhone, security cameras, access controls, management systems, how to isolate these things. These can be placed in isolated VLANs. Okay, so it reduces the visibility and also the exposure, right? And also separate critical control traffic. Also, routing protocol updates, switch managements, everything can be given to restrict the access to the switch. Okay, so the switch management interface can be dedicated for the VLAN. Only the authorized users can reach out. So it can help to prevent the tampering or else the unauthorized access. Okay, so it improves the security and also it simplifies the troubleshooting. Right? So what are the bad reasons to use VLAN? So because you feel cool, you cannot use. So VLANs add complexity. They require careful planning. Using them just for fun, always it causes configuration errors. Okay, unmanageable designs, it leads to complexity. Okay, so because they will completely secure your host, in that case, that is your, if that is your perception, because VLANs will completely secure your host. No, it is a myth. VLANs, it is not for the security. VLANs are not for the security mechanism. Okay, that is for separating the traffic. Okay, it isolates the traffic, but they do not encrypt the data or they do not provide the access control. Okay, VLAN there is a possibility of attack, there is a possibility of misconfiguration, there is a possibility of exposing the sensitive data in the VLAN. Okay, in that case, for securing the host VLANs, no, that is not the reason. Okay, and also because VLANs let you extend the single IP network across separate buildings, that is also extending the same layer 2 network broadcast domain. No, it leads to broadcast storms. Okay, it will be creating troubleshooting nightmares. Okay, with the help of layer 3 uh, routing between the buildings, only you can go for stretch the VLAN. Okay, so VLANs, of course, you can use, but not a magic solution. Okay, you have to use them. You have to plan them appropriately. Uh, you cannot just because you cannot use it. Fine. So do not build VLAN Sagapti. So extending the same VLAN across multiple buildings using trunk ports, okay, broadcasts from one device forwarded to all the trunks and all the buildings in that VLAN, definitely it will waste the bandwidth and it will increase the congestion. Okay, so and it can lead to broadcast stop. So misbehaving device, if it causes the broadcast stop, it will be propagating throughout the entire network. Okay, so there is a single point of failure can affect the entire campus. Okay, so there will be difficult in troubleshooting also. The problems in one building will impact the devices in other buildings as well. Why? Because we have connected each other. Okay, so you have to make the isolation of the uh, that will be very harder. Okay, complicates the maintenance. Okay, so why? Because if 10 buildings are there, 10 are connected to the same VLAN network. So if one VLAN is misbehaving, so I have to go and check it out all the 10 buildings. Okay, so VLAN changes, they require careful coordination across all the trunk links. Okay, high chance of misconfiguration. It leads to increase the bandwidth, decrease it, congestion. So if there is a congestion, downtime will be there. So even during the updates, downtime will be there. So best practice, you have to route between the VLANs across multiple buildings, but with the help of layer 3 switch, you have to keep the VLANs localized uh, as much as possible. Okay. Any doubts? Any doubts?
No, ma'am.
What about the quest, whether it is scheduled? Please check it out. Can you able to access the quiz? No, can you able to access the quiz?
It's not showing, ma'am, yet.
No. No. Just a second. I'll check it out.
I'm not sure. Is it for me only?
What about others?
It's showing.
Kindly refresh, ma. You can access the quiz, right?
Yeah, ma'am. Now I can so.
Complete the quiz, please. Please don't leave the meeting. Complete the quiz, post it in the chat box, and then leave the meeting. As such, don't leave the meeting, ma. Students, please don't leave the meeting. Complete the quiz, post it in the chat box, and then leave. Done. Okay. So if possible, I'll upload the video in the Teams, how to configure the VLAN on a switch using Cisco Packet Tracer. Kindly go through it. Okay, if you've completed, you can leave the meeting now. Thank you. Okay, Ma, I'll upload the slides in the Teams as well as if possible. If time permits, I'll create 1 or 2 videos and I'll upload in Teams how to configure uh, the VLAN, okay, using Cisco Packet Tracer, VLAN routing, how it happens. I'll upload it in the Teams as a video. Okay. So, I'll end the meeting. Make sure you're completing the quiz. Fine. Thank you, ma'am.